Hello friends, welcome to Risingpearl.com. We are talking about series 2 where we are learning about triangles. Today is webisode number 26. Friends, today we are going to take a look at solving questions related to Pythagoras theorem, and this is our part 2. In webisode 25 we started taking a look at these type of questions, and that was a part 1. I'm going to provide a link below for your easy reference. So let's continue our journey to look at what kind of questions you may be getting in your tests that may be based on Pythagoras theorem. So a ladder is placed against a wall. Our question number 1, question 1 is a ladder is placed against a wall such that its base, that is the base of the ladder, is at a certain distance 2.5 meter away from the wall, and the top of the ladder reaches an object 6 meter above the ground. Find the length of the ladder. So how do we do this? So friends, as you can see, we don't have a shape or a figure given to us. So we have to draw it by ourselves. So first is we draw a right angle triangle such that, say AC is the ladder. Here AC, this is our ladder, right? So AB, think about this entire line, imaginary line, as your wall. AC is the ladder and BC is the base of the ladder is away from the wall, that is BC, right? So this line, if you think about it this way, right? If you were to extend this like this is the ground level, AC is the ladder. So BC is the distance, how far away the ladder base is from the wall. And if you again think this way, dot dot dot, so this line is the wall and AB is the height of the object above the ground. So what is given? AB is given to be 6 meters. This is 6, right? BC is 2.5. This is 2.5. This is 90 degrees, and we have to find AC. So as you can see friends, quite simply we can see that ABC is right angled at angle B, right? From Pythagoras theorem we know AC square is equal to AB square plus BC square, right? So if you just to put the values in, so AC square is equal to 6 square plus 2.5 is nothing but 25 by 10. So 36 plus 25 square is 625 by 100. So if you solve it, you will get AC square is equal to 4225 by 100, which now you have to apply square root on both sides. So applying square root, because you have AC square equal to this value, applying square root on both sides, you will get AC is equal to 65 by 10 or 6.5 meter. So this length will be 6.5 meter, which is the height. AC is nothing but that is the ladder, how long the ladder is, and we see that AC or the ladder is 6.5 meters long. So friends, this is one type of question that you will get where you apply directly Pythagoras theorem and solve the question. The second type of question, friends, is something like this. Here what you will be given is, given below are 3 sides of a few triangles. So question 2 actually has 4 separate questions, A, B, C, D. So given below are sides of a few triangles, which of the following is right angled triangle? So how do we know? So we know that friends, for if I have been given 3 sides, that means if you imagine a right angled triangle, and it doesn't matter which of the angle, whether angle A or angle B or angle C, that you assume to be a right angle triangle like 90 degrees. So in this case I have just drawn a right angle triangle with angle B 90 degree. So what we know is, from Pythagoras theorem, the hypotenuse square is equal to the sum of squares of other 2 sides. AC square should be equal to AB square plus BC square. So if I am given the 3 sides, that is, if these values are given, So AB is given, BC is given, and AC is given. I have to check which triangle, if each of these triangles are actually right angle triangle. So what we can say, friends, is in each of these examples, in each of these questions, I am going to find out if this relationship is true. If this relationship is true for the triangle, then we can say yes, that triangle is right angle triangle. The other thing, friends, we have to find out is, we know that AC, or the hypotenuse, is the longest side. So let's take a look at the first question, which is A, 3, 4, 5. So 5 is the longest side. So what I'm going to do is I'm going to first find out 5 squared. 5 square is 5 times 5, which is equal to 25, right? Then I'm going to find out 3 square. 3 square is 3 times 3, which is equal to 9. And 4 square is 4 times 4, which is equal to 16. Now I'm going to add these two and see what we get. So if you add these two, you will get 9 plus 16, which will be 25, which is exactly what we have here. That means in this first example here, we have 5 square equal to 3 square plus 4 square. So I don't know which of the angle is 90 degree, but I do know that this triangle, or any triangle with this dimension, is indeed, yes, this is a right angle triangle, because Pythagoras theorem holds good for these sides with these dimensions. So I can say, because Pythagoras theorem holds good for these sides, that these sides are part of a right angle triangle. So similarly, friends, you can do it for all the other cases here, right? So again, remember that AC, which is the hypotenuse, is the longest side. So for example, if you were to take a look at question number D, right? Here, this one, you are looking for the longest side, and that will be the hypotenuse. So in this case, you are going to square, 25 square will be hypotenuse. Then you will do 24 square, and you will do 7 square, and then you will add the other two and see if that sum is equal to 25 square. So this is your second type of questions that you may be getting on right angle triangles or Pythagoras theorem. Now friends, let's take a look at one other type of question. Here, an aeroplane leaves an airport and flies north at a certain speed. At the same time, another airport leaves the same airport and it flies west at a certain speed. So friends, what we have is, looks like we have an airport, and there is one aeroplane that is flying north at a speed of 1000 km per hour. At the same time, another aeroplane, second aeroplane, is leaving the same airport, but it is flying west at a speed of 1200 or 1200 km per hour. How far apart will the two planes be after 1.5 hours? So friends, one thing is that from a direction standpoint, right, if you draw a plus, you know that this is north, this is south, north, south, west, east. These are the directions. So how do we solve this question? So we take a point R, and then we assume this is the starting point for the aeroplane, and one aeroplane, the first aeroplane, is flying north. That is, this is R, start here, and this aeroplane flies north. So starting point R, and it goes north. So after 1.5 hours, let us say Q is the position of the aeroplane. So RQ is the distance the plane has traveled in 1.5 an hour, right? Similarly, friends, what we can say is at the same time RP is the distance traveled by the second aeroplane. So let's say at 1.5 an hour, after 1.5 an hour, the second aeroplane, this is flying west. So see here, so this is north and this is west. So P is the position of the second aeroplane after 1.5 an hour, right? So now, so what is the distance between the two aeroplanes? If you simply join PQ, this is going to give you the distance between the two aeroplanes after 1.5 an hour. So friends, as you can see, this is a simple question of, so what we have here is, this is 90 degrees because this is north and this is west. So this is 90 degrees. Now what is RQ? RQ directly is not given to us, but RQ is the distance traveled by the first plane. So we know that speed is equal to distance traveled by the time taken to travel that distance. So speed is distance by time, right? So to find the distance, let's just write it in short by D. It will be nothing but speed multiplied by time. So if you look at, for the first aeroplane, we have been given the speed. Speed is 1000 kilometers and time taken is 1.5 an hour. So if you just put the value of speed and time, you can find out the value of RQ. Let us just call it X, right? Similarly, for the second aeroplane again, speed of the second aeroplane is given also 1200 km per hour, and it is flying in the same, it takes the same time to get to point P. So again, by substituting the value for speed and time, you can find out the second distance, that is distance traveled by the second aeroplane. Let us call this Y. So what you have is triangle PQR is a right angle triangle, right angled at R. So applying Pythagoras theorem, PQ square is equal to X square plus Y square, right? Because Pythagoras theorem tells us the hypotenuse square is equal to the sum of other two squares, right? The sum of the square of other two sides. So PQ square is equal to X square plus Y square. And please note that you actually know the value of X square, Y square. So PQ from here, this implies that PQ, which is the distance between the two aeroplanes, this is the distance between the two aeroplanes, is nothing but square root of whatever the value you will get here, X square plus Y square. So friends, I am actually not solving the question for you, but I am giving you the overall approach of how you will go ahead and answer these type of questions. So again, if you think for a moment, friends, if in the beginning, if you were given a right angle triangle and if the value of X is given and value of Y is given, and if they ask you simply find PQ, it would have been such a simple straightforward question. But here they did not, the question did not give us any figure, and this is a question expressed in words. So initially it looked like a pretty complex question or somewhat difficult question, but what it is really is simply a right angle triangle given to us with two sides. We have to find out the hypotenuse. So friends, now let's take a look at probably one last question before we wrap up this webisode. So here, question number 4. Two posts of heights 6 meter and 11 meter, they stand on a plain ground. So I've got two posts, maybe goal posts, maybe soccer post or something. So I've got two posts of different heights, 6 and 11 meter respectively, stand on a plain ground. If the distance between the feet of the posts is 12 meter, find the distance between their tops. Again, we don't have the shape or figure given to us, so let's draw it by ourselves. So we draw a straight line, a straight horizontal line. which basically represents the plane or the ground. We draw one post, right? Let's say this is the smaller of the two posts. Then we draw the long post, right? So here, friends, this is the ground. This is the ground. This is the small post, right? Small post is 6 meters. So we drew this line a little bit smaller. So this is, let's call this, this is our post 1, this one. And this is our post 2. Post 2. So post 1. This is a post 2. Now if the distance between the feet of the posts is 12. So this post and this post, so this the distance between the feet is this, right? Which is nothing but how far away the two posts are from one another. This is the distance between the two posts. What we need to find out is distance between their tops. So we have to find out this distance, right? So essentially what we have to do is we have to find out this distance. So let's just join that. So now, friends, so if you think about it, what we have is we have been given a shape. This is actually a trapezium. So let us just name this. So we will name this, let's say A, B. Let's call C, D, right? So we have been given AB. AB is 6. This length is actually 6, right? CD is 11. CD is 11. And BD is 12. BD is 12. We have to find out AC. The way we are going to solve this question, friends, is we are going to do one simple construction. From A, we are going to draw a straight line which is basically parallel to the ground. So we're going to draw a straight line intersecting CD at, let us just say this point is, let's call it P. And the reason we want to do this, friends, is because we want to have a right angle triangle here, because this is the length we need to find, right? AC. If I draw a right angle triangle like this, then I can say that AC square is nothing but it is equal to CP square plus AP square, right? Because this is a right angle triangle, triangle ACP, this is 90 degrees. If this angle is 90 degrees, then this angle is 90 degrees because AP is parallel to BD and our CD is a transversal. So both angles are 90 degrees. So this triangle ACP is a right angle triangle. So since we have to find out the length AC, we can say AC square is equal to CP square plus AP square. So what is CP? Remember, the whole length for CD is 11, right? So if this is 6, AB is 6, then PD, this length is 6. That means this length is 5. So CP is equal to 5. So it is 5 square plus. What is AP? AP is equal to BD. Why? Because if you look at this, so AB is basically you have, so this angle is 90 degree, this angle is 90 degree. So you can prove that AB, AP, DB is a rectangle. 90 degree, 90 degree. These two lines are parallel to each other. And these two lengths are actually, so similarly you can prove that all of these angles are 90 degrees. So you have a parallelogram with both pairs of opposite sides parallel to each other, and this angle is 90 degree. So this APDB is a rectangle. So if this length is 12, AP is 12. So instead of AP we are going to put 12. So here, friends, you will know that this is 25, 5 square is 25, plus 12 square is 144. If you add them, you will get this as 169. So AC square AC square is equal to 169. So taking square root on both sides, you will get AC is equal to square root of 169, which is going to be 13. So AC is 13 meters. That is, the distance between the two tops is 13 meters. So this distance between their tops is 13 meters. So friends, we hope that you are following us along at risingpearl.com. We have gone through different kinds of concepts in this particular series, and this webisode actually wraps up all of the different types of questions that you may be getting on questions related to right angle triangles and Pythagoras theorem.